Hi students, I am Mr. Shiva Prasad from Civil Engineering Discipline. I welcome you all to the video lecture in Engineering Mechanics. In this video, we shall understand the module on friction. So to begin with, let's look into the contents of this video. We initially begin with the introduction to friction. Then we understand the phenomenon of friction, coefficient of friction, laws of friction, angle of limiting friction, angle of repose, and cone of friction. Okay, the introduction part. Friction is a phenomenon that occurs in our day to day life. Yes, it's a day to day life phenomenon. It is a natural phenomenon also. It is a natural phenomenon that occurs when there is contact between two objects. As for this, the best example would be that you experience every day is slowing down of vehicles on the road surface. Yes, that can be the best example which everyone would have looked into. So now from engineering mechanics point of view, let's understand what exactly is friction. When a body moves or tends to move over another body, a force opposing the motion develops at the contact surfaces. This force which opposes the movement or the tendency of movement of the body is called frictional force or in general friction. So please note that frictional force is the force which opposes the movement of the body. So let's understand the phenomenon of friction. For this, we'll consider an example. Let us consider an example of a block of weight W to be resting on the horizontal surface, due to which there comes into picture a normal reaction force N at the contact surface. Now, this block is pulled by an applied force P. That's just observe the direction of P. We have considered it along the right side of the block. Due to this, there arises the frictional force F in the direction opposite to the applied force. Yes, please note that the direction of frictional force F is in opposite direction of the applied force P. So let's look into the graphical representation of the same example. So for this, I shall choose the applied force P on the x-axis and the frictional force F on y-axis. Initially, before applying the force P, the frictional force is also 0. On gradually increasing the value of P, that is the applied force P, the frictional force also shall increase gradually and reach a limiting value. So this limiting value is termed limiting friction, represented by F max. At this stage, the block is in the verge of moving. It's just about to move. At limiting friction, the block is about to move. So this state we describe as the motion is impending. Please note that the stage at which the block is about to move, it is termed as the motion is impending. And immediately at this stage, there is a drop in the value of frictional force F up to some extent. And on further increasing the value of P, the value of F continues to remain constant. That is, the frictional force remains at a constant value even after increasing the applied force P. The excess value of P after limiting friction is completely utilized in the motion of the body. That is, uh, after limiting friction, the block has begun to move. So that applied force P, which is in excess of after limiting friction, it is completely utilized in bringing about motion to the body. So here we can observe two parts which has happened. So the first part would be 0 applied force 0 to a limiting value, that is up to limiting friction. So this portion is described as static friction represented by Fs, and that portion of the graph after limiting friction, it is termed kinetic friction or dynamic friction represented by Fk. So let's note the definitions of these uh, static friction and dynamic friction. So the maximum value of frictional force which comes into play when the motion is impending is known as limiting friction. Yes, please note that the frictional force when the motion is impending means the block is about to move, that stage is defined as the motion is impending. So the maximum value of frictional force which comes into play when the motion is impending is known as limiting friction. And when the applied force is less than limiting friction, that is up to limiting friction, the body remains at rest. Yes, up to limiting friction, the body, no matter a force P is applied, the body still remains at rest. And this state, up to this state, the frictional force is called static friction. Its value ranges between 0 to limiting friction. And further, if the value of the applied force exceeds the limiting friction, so after limiting friction, the body starts moving over the other body or on the surface, and this state of frictional resistance experienced by the body while moving is known as dynamic friction. So these are the definitions of limiting friction, static friction, and dynamic friction. And please note that the dynamic friction value is always less than limiting friction. So again, we note that dynamic friction may be classified into the following two types, that is sliding friction and rolling friction. So sliding friction is the friction experienced by a body when it slides over the other body, and rolling friction is that friction experienced by a body when it rolls over a surface. So rolling friction best examples would be those objects which are supported on roller supports, and sliding friction you can just consider any object placed over a simple support. Coefficient of friction, let's understand this. So the limiting friction is directly proportional to the normal reaction force. Yes, please visualize the example what we had considered before. So wherein the normal reaction force which is due to the weight of the block, uh, the limiting friction will be directly proportional to this normal reaction force. So we say the limiting friction, that is represented by F max, is directly proportional to N. So constant, removing the proportionality symbol, we add a constant of proportionality mu, that is F max is equal to mu into N, where N is the normal reaction force. So let's see what is this constant of proportionality. So the ratio of limiting friction to normal reaction is a constant. So this constant is known as coefficient of friction. So the equation for coefficient of friction would be mu equal to F max divided by N. So with this information, let's list the laws of friction. So it is also termed laws of dry friction, or it is also termed Coulomb's law of friction. Okay, the first point, the frictional force always acts in a direction opposite to that in which the body tends to move. Yes, this is what is the thing we have first seen in the definition. Till the limiting value is reached, the magnitude of friction is exactly equal to the force which tends to move the body. Okay, the magnitude of the limiting friction bears a constant ratio to the normal reaction between the two surfaces of contact, and this ratio is called the coefficient of friction. Yes, so this is the definition of coefficient of friction that we have seen already. Next, the force of friction depends upon the roughness or smoothness of the surface. Yes, this law is oriented on the surface phenomenon. Okay, that is, if the whether the surface is rough or smooth, based on that the force of friction would depend. Next, further, the force of friction is independent of the area of contact between the two surfaces. Yes, it is not at all dependent on the area of contact, because we have seen the limiting friction is completely it's completely proportional to the normal reaction force. And next, finally, after the body starts moving, the dynamic friction comes into play. Yes, after the body has moved, that is, in that graphical representation we have seen. So after the body starts moving, the dynamic friction comes into play, the magnitude of which is less than that of the limiting friction. Yes, and it bears a constant ratio with normal reaction force. So this is called coefficient of dynamic friction. So we have seen coefficient of static friction represented by mu in the previous slide, and this is coefficient of dynamic friction. So all these six laws are going to define various uh, phenomenon, the various stages in the entire phenomenon of friction. So the first point says you about the sense of or direction of the frictional force. The second law discusses about the limiting value of the frictional force. The third point is nothing but definition of coefficient of friction, and the fourth point says that frictional force depends on the surface, and the fifth point, it is independent of the area of contact, and sixth point is about the coefficient of dynamic friction. Please remember these 6 points, and you will have to present them as they are defined now. Next, let's move on to another important point under friction, that is the angle of friction. So let's consider the same example wherein we have a block of weight W. So it is placed on a horizontal surface, and due to this weight of the block, there exists a normal reaction force which is acting from the downward direction at the point of contact, and it is subject this block is subjected to a horizontal pull, due to which a frictional force would come into picture in the opposite direction to the applied force P. So now this two forces, that is frictional force F and the normal reaction N, they are called as the support reactions, or they are the reactions at the contact surface of the block and the horizontal surface. So these two reactions can be combined graphically to get the reaction R. So just observe these two forces, that is the frictional force F and the normal reaction force N. These two combinedly, we can replace them with a reaction force R. So now the angle between this reaction force R and the normal reaction, let us represent it by theta. So this angle theta is called angle of friction. It is given by tan theta is equal to F by N. So you can just uh, imagine that this these three forces F, N and R, that is the frictional force, the normal reaction and the resultant force, that is the reaction R with respect to F and N, they three form a triangle, a right angle triangle, and tan theta is given by F by N. So let's call this as equation number 1, which we will be using it further. So to define angle of friction, it is nothing but the angle made between the normal reaction force and the reaction force R. Next, moving on to angle of limiting friction represented by alpha. So we have seen angle of friction theta in the previous slide. Let us see how this angle of limiting friction is different from angle of friction. So consider the same example, that is a block to be resting on the horizontal surface. So subjected to a force P. So we have the frictional force F and the normal reaction N coming into picture. So R is the reaction between F and N. And now let's consider the uh, entire phenomenon wherein the block is in the verge of moving. That is, let's consider a stage when the motion is impending. So definitely at this stage when the motion is impending, we call the frictional force F as limiting friction, and we represent it by F max. So this maximum value of limiting, at this maximum value of limiting friction, even the value of theta will also be maximum. So this maximum value of theta when F has reached its limiting value F max is called angle of limiting friction. So till now with the say the angle of friction, whatever we used to call it as theta, will be replaced by angle of limiting friction, that is alpha. So what is that we need to understand here is angle of limiting friction alpha is nothing but the angle of friction when the motion is impending. So this is what is angle of limiting friction. So at this stage, tan alpha is equal to F max by N. Yes, we need to consider, if we say limiting friction alpha, means we need to consider the limiting friction F max divided by N, and this is equal to mu, that is a coefficient of friction. Next, this value of alpha is called angle of limiting friction. So hence we can define angle of limiting friction as the angle between the resultant reaction and the normal to the plane on which the motion of the body is impending. Please note that angle of limiting friction alpha is the angle of friction when the motion is impending. Next, angle of repose. So let's consider the same example, but now in this case the block of weight W is placed on an inclined plane. So let the angle of inclination be theta. So now there would be a normal reaction force which would be perpendicular to the inclined plane at the contact surface of the block, and there would be a frictional force in the opposite direction of motion of the block. So now let's increase the value of theta slowly. So on gradually increasing the value of theta, a stage is reached at which the block will begin to slide down. So please observe, when we slowly increase the angle of theta, when we slowly increase the angle of theta, that is the angle of inclination, the block will begin to slide. So this angle theta for which the motion is impending, that is the block will begin to move. So this angle of theta for which the motion is impending is represented by phi, and this phi is called angle of repose. So that means to say, for any block kept on an inclined surface and on increasing the angle of inclination, the when the block is in the verge of moving, that is when the block is in the verge of sliding, or the stage is described as the motion is impending, at this stage the maximum angle of inclination is referred to as the angle of repose. So from the previous equation, tan theta is equal to f by n. So when the motion is impending, the value of theta we are replacing it by the angle of repose phi. So then the above equation can be written as tan phi is equal to f max by n, and from the previous equation, that is we have tan alpha equal to f max by n, that is equal to mu, angle of limiting friction. So therefore we can say tan phi is equal to tan alpha, or it can be written as phi is equal to alpha. So what is the inference here is the angle of repose is nothing but the angle of limiting the angle of repose is nothing but the angle of limiting friction. Okay, so let's move on to the last heading, that is cone of friction. So again, considering the block on the horizontal surface, we have this normal reaction n, and and on application of the force P on right side, we have this frictional force to be acting in the opposite direction of P, that is the frictional force F acting in the opposite direction of P. So when a body is having impending motion, let's start to understand cone of friction from the impending motion stage. Okay, so when a body is having impending motion in the direction of force P, the frictional force will be limiting friction. Yes, that's what we have seen till now, and the resultant reaction R will make limiting angle alpha with the normal. Yes, that is what is alpha. And now if the body is having impending motion in some other direction, so let's say we have inclined the direction of P itself, then definitely the friction developed will also be in a different direction. So that's what we say here. If the body is having impending motion in some other direction, the resultant reaction makes limiting frictional angle alpha with the normal to the direction. So thus, when the direction of force P is gradually changed to 360 degrees, please note, when the direction of force P is gradually changed through 360 degrees, the resultant R generates a right circular cone. The resultant R generates a right circular cone with semi-central angle equal to alpha. So if the resultant R is on the surface of this inverted right circular cone whose semi-central angle is limiting frictional angle alpha, the motion of the body is impending. If the resultant is within this cone, the body is stationary. So please understand, there generates an imaginary cone whose apex is at the tip of the normal reaction force. If R, that is the reaction force between F and N, is lying on the inclined surface of this cone, then the body is impending. Or if the reaction force R is within this cone, then the body is stationary. So the cone of friction is used to state to just describe the state of the body, whether it is in motion or whether it is stationary. So please note that if the reaction force R lies on the inclined surface of the cone, then that is to say that the body is impending, it is just about to move. So if R is further increased above the angle of inclination alpha, then the block will be in a moving stage. But if R is having, or if R is inclined at an angle less than alpha, then the body is stationary. So this is the concept of cone of friction. So with this we can define the cone of friction as the inverted cone with semi-central angle equal to limiting frictional angle is called cone of friction. Okay, so with this we have come to the end of the video. So please note that for engineering students, in semester and examinations, each and every heading what we have discussed till now will be for, say, up to some from 4 to 6 marks. A definite question you can expect, and this video will has made you, I think this video has made you easy in understanding the concepts and as well as writing the notes on your own. So please don't forget to subscribe to this channel Civil Aid, and further in the upcoming videos we shall take up problems on ladder friction and belt frictions. Thank you.